So that's the pattern for a positive sine wave. If you've got a negative sine wave, the middle values, it reflects vertically over that midline. The middle values will stay the same, but highs will turn into lows and lows will turn into highs. So where on this wave would be the beginning of a negative sine wave? Somewhere where it goes middle then low. So this one here could be the start of a negative sine, or this point here. Either of those could be the start of a negative sine. Let's choose this one here. You can see it's going middle, low, middle, high. Okay, so now do the same for a cosine and a negative cosine. Write out the patterns while I try and set my camera up. And then on your sheet of paper, answer the other two questions too. Pattern for a cosine starts with a high. Goes high, middle, low, middle, high. So either this point here, or this point here, or this point here. Any of those points could be the start of a positive cosine. Let's choose this one. And then it would go high, middle, low, middle, high. That would be the end of it. This one would be the end of a positive cosine and the start of the new one. And a negative cosine goes, the highs turn to lows, the middle stay the same, and the lows reflect to become highs. Okay. So we can start on any low point. We could start here. This could be the start of a negative cosine wave. Or this one could be. Or this one here could be. Any of those could be the start of a negative cosine. Okay? Right. When we look at any of these waves, the period of the parent sine function, parent cosine function, is when it's gone through its entire pattern. So say from here to here, that length there is 2 pi. It's the same for a cosine. You could measure it from here to here, from peak to peak, trough to trough, midpoint to midpoint, as long as you're going from a midpoint to a high, midpoint to a high, not between these. That's only half a period, that's only 1 pi, okay? But the period for both of them is 2 pi. Now, the amplitude, type into chat, what do you think the amplitude of that wave is? Everybody, type it in, let me see what you're typing. Into chat, here we go. Oh, some of you getting it wrong. Yeah, some of you are choosing the right number, but what amplitude is? Amplitude is the distance between the midline and the high, or the midline and the low. It's just a distance. It is never, ever negative. The amplitude on that wave is 3, not -3. If you write -3, your answer is wrong, okay? So for that, the amplitude of that wave is 3, not -3. It's always positive, okay? Because it's just a distance. Now, how would we find out the maximum? On the parent wave, the maximum is at 1 and the minimum is at -1. That's for the parent. What about for this one? Okay, type in what you think, type into chat what you think the highest point will be. Let's see what we're getting. Contributions, everyone. Oh, I've got lots of them coming in. Well done. And I can only see 2 that are wrong so far. Lots of you aren't contributing here. The high is where those peaks will be. The label on your graph, the part you label as the high, there's a couple of you need to change your answers. Okay? If I was graphing this, I would have a midline, a high is your maximum, and the low would be your minimum. The midline is going to be at 4. You're going to go 3 up and 3 down. So the high is going to be at the midline plus the amplitude. So it's going to be 4 plus 3. It's going to be at 7. And your low is going to be at the midline going down by 3. Okay, so it's going to be at 1. Right. Now something a little tricky again. Still working on that sheet of paper you're handing in at the end of class today. But we're going to do a horrible graph in a minute, but I want to make sure you're ready for it. So do not graph this equation, but write this equation. So write this down on your sheet of paper. And rewrite in graphing form. Which means factor out the b. And your b here, that's 1/5. That's supposed to be a 5. Factor that out. So imagine your start is not going to be, if you write x equals pi over 2, you're wrong. Something else. Okay, I'll give you a minute or so to fill in those, to try and work on that on your own for a minute. You don't have to, I want it on your piece of paper, okay? You don't have to type it in. Could I scroll up? There's nothing up. That's it. Sophia, are you here?
Yeah, I'm here.
Okay, I can't see you. I can see you've responded. So yeah, you're there. You're right there in the middle of the screen. I missed your name. Somebody's missing, that's all, who hadn't messaged me. That's all. Trying to work out who it is. Okay, so does anybody want to volunteer? Does anyone want to turn their microphone on and tell us what do you think the start will be? How do you work it out? To find the start, you're factoring out 1/5. So this has to be divided by 1/5. So you're doing pi over 2 divided by 1/5. Remember, you just multiplied by the reciprocal. It's going to be at 5 pi over 2, 5 halves of pi. So if you had a piece of paper with pre-labeled with like pi here, 2 pi here, you're only starting, around about there, okay? What would the period be? How do you work out period? The equation you should be using is 2 pi divided by b. So you've got 2 pi divided by 1/5. What does that give you? Okay, type it in. Don't say it. Type it in. Let's see what you're writing. Be bold. Everyone, type something in for me. please. Not everyone's being bold enough to answer. You're waiting for me to fill it in. Just mostly getting it right. Couple getting a slight mistake there. Remember how to divide by a fifth? You multiply by the reciprocal. So you've got 2 pi times the reciprocal, 1 over. Flip it upside down. Gives you 10 pi.
10 pi.
Yeah, 10 pi. So what's your step? The other word we sometimes use for step is the quads. The quad, you get that period, and you have to divide it into 4. There's 4 steps make up a full period. So it'd be 10 pi divided by 4, which gives you 5 pi over 2, 5 halves of pi. Oh my goodness. So I haven't, if this was the midline, if this was y equals 6, and the high would be 3 above it, so that would be at 9, and the low would be 3 below it. Ooh, this is terrible. Our graph would start at 2 halves. It's the negative sign, so start on the midline there. And then you'd have to go 5 halves of pi. So we have 4 pi, all the way over here, 5 pi, before you next went to negative sign. Middle, low, middle, high, middle. If you did a low all the way out here, and if you went back 5 halves of pi, 1 half, 2 halves, 3 halves, 4 halves, there'd be a point on the y-axis here that would be the, going backwards, that would be a high. Your wave is really, really spread out. A horizontal compression of a fifth doesn't compress the wave, it actually really stretches it out horizontally. Okay, right, are you ready to graph something really disgusting? Try it on your own and leave what you've done, and then when I go over it, redo it, okay? But I want everybody to have a go at graphing this one now. I'm telling you, it's mean, it's horrible. So how long shall I give you? Shall I give you about 3 minutes? See how far you get in 3 minutes. Off you go, guys. Okay, so let's have a look at this. First of all, in graphing form, you're going to have to factor out this 4. If you factor it away from the x, you also have to factor it away from that. Divide out by it. When you're dividing, it goes down in the denominator. So our graphing form is actually y equals -2 cos of 4 times x plus, that would just be pi over 3 minus 1. Write down. Your midline is going to be at -1. Your amplitude is 2. So we're going to start on -1. And we're going to go up by 2 and down by 2. So this is going to be at 1 and this is going to be at -3. So don't forget, you're submitting this sheet of paper that you're doing all this on. It's really a completion grade. The more time you, don't wait for me to do everything. The more time you actually spend doing them on your own, the better. So our start is going to be at, here's our start here. So once it's factored out, it's going to be at x equals -pi over 3. Now don't graph, if you haven't done it on your own yet, don't graph what I'm about to do, because I'm going to have to change this. If I just put that at -pi over 3 and said my pattern is a negative cosine, so negative cosine goes low, middle, high, middle, low. But if I could get that far, get those lines on and put this point on the low line at -pi over 3 and put a circle around it, that's over half of the points for this question. And I haven't even really graphed much at all. But please, on the quiz tomorrow, you can get something on all of these, okay? I'd want to see that label very clear and these labels very clear, and your start one on that low line circled. That will give you lots of points. Now I'm going to show you in a minute why I'm going to delete that. Your period is 2 pi divided divided by the value of b. Our value of b is this 4 up here. So it's going to be 2 pi divided by 4, which is pi over 2. And that's going to mean from the low through the wave to the next low, that distance there from one to the other is going to be pi over 2. But this first one's at negative pi over 3. Ugh. It's going to be a right mess. You're getting some feeling this is going to be difficult. Your quad is also known as your step length, and each wave is divided into 4. So that would be halfway, that would be a quarter of the way, that would be 3/4 of the way. And that's where we're going to graph these points. So we get that period and divide it in 4. Well, our period is pi over 2. And the easiest way to divide by 4 is to multiply by the reciprocal, multiply by a quarter. So we get pi over, oh, that's not pi. We'll get pi divided by 8. Okay? Now, that's going to be very difficult to graph, because if I've got this pattern, let's move it down a little bit. I'm going to start at negative pi by 3. These are y values, these are x values, so that would be 1 point. But to get to the next point on the midline, I have to add on pi by 8, and that's awkward. Remember what we said on Friday, that your start and your step need the same denominator. So if you've got negative pi over 3 and you've got pi over 8, what could rewrite them as a fraction with the same denominator? The lowest common multiple I can think of for them is actually 24. You're having to multiply this one by 8, so you multiply it by 8 over 8, and this one has to be multiplied by 3, so you're multiplying it by 3 over 3. This would be negative 8 pi over 3, that's your start, and your step is, no, over 3, what am I doing? 8 times 3, 24. And this one would be 3 pi over 24. So that start, it is negative pi over 3, but I'm rewriting that as negative 8 pi over 24. And the step size I'm adding to it is 1/8, but I'm rewriting it as 3/24. Okay, now it's doable. If I have negative 8 pi over 24, that's this start, and I add on this step, that will give me this value here. It's going to be negative 8 of them plus 3 of them gives you negative 5 of them. Take 30 seconds, work out the other points where this high, this middle, and this low are going to be. Work out these fractions here. Okay. So this would be, you add 3 pi over 24 to that. This would be at negative 2 pi over 24. This one would be at positive 1 pi over 24. And this one would be at positive 4 pi over 24. Right, so these values here are going to have to be our values on our x scale. Now do you see why this would be terrible to have this here? I'd have to get in 3 points before the y-axis. So let's not put it here. I don't know, let's move it maybe back this far. If you've got squared grid paper, I'm actually going to count back 8 and think of each one of those as a 24th. 1, 2, 3, 4, 5, 6, 7, oh, it'd be, I count back 8 squares. That's my negative 8 pi over 24. Now you can write it as negative pi over 3. You can reduce it if you want, or you can write it as negative 8 pi over 24. But that label needs to be on your x-axis. We need a label at negative 5 pi over 24. This one here. And as you'll see, that's a step of 1, 2, 3 of our marks. And each of our marks is 1 pi by 24, each grid. Then we've got one at negative 2. Then we'd want one at 1, 2, 3. That'd be at pi over 24, and another 1, 2, 3 squares. So this one is at pi by 24, and this one here is at 4 pi by 24. So that's going to be one wave. Now we're just graphing our pattern. We started on the low at minus 8 pi by 24. Now I'm going to graph at this x value. I'm going to graph this y value. So at minus 5 pi by 24, I'm on the midline. Then I'm going to get the high line at negative 2 pi by 24. Then I'm going to be back at the midline. Notice there is no point when x equals 0. There's no point on the y-axis. So on the midline there, and then at 4 pi by 24, we're on the low. Now graph that in as a wave, make it smooth and continuous. And we only managed to fit on one cycle going forwards. It would be, you'd really have to crush in that scale to do another cycle going backwards. Remember, when you glance at your graph, it should look like we're graphing some part of this. We were graphing, say, from there to there. But they go on and on and on forever. But they should look nice and smooth and rounded. Okay, now I don't know how this next part's going to work for you guys. It's going to be a little odd. I hope you've got that all graphed beautifully on your piece of paper. Now, for my in-person classes, they've done this group exercise where they were passing a sheet of paper around the room. Now, you guys can't do that, so we're going to, right. Can I delete that? Yeah. Right, what we're going to do is choose for me. First person wins. Type in either sine or cosine. Somebody type something in. Who gets it? Type in just sine. Okay, so I got son. Okay, right. So Zach, I think you were the winner there. Okay, you can stop, guys. Everybody, turn, if you were using a piece of paper, turn to the back now. Okay, start a new piece of paper with your name at the top. Right, y equals sine of x. So we're all going to have the same. So we've got y equals sine of x. Now, what my other classes were doing, they would write that, then they would, as their group, they'd put in one transformation by putting in a value for A, B, C, or D, and then they have to describe what it's going to be. So, shall we do, we're going to have to do this together. It's a bit boring, a bit weird. Let's choose a midline. Somebody give me a number. First person to type it gets it. Give me a number. 4, okay? D equals 4. So, write on your piece of paper beneath where you wrote y equals sine of x, let's put y equals sine of x plus 4. Now you have to, underneath that, write a little sentence. Describe how that changed the wave. Describe in words the transformation. on your piece of paper that you're submitting at the end of class today. Would anyone be really nice and make sure everyone else is with them? Somebody open up their microphone and tell everyone, what did you write? Do I have a volunteer? Shall I ask someone? Shall I randomly choose a person? That would be mean, wouldn't it? Come on, someone be brave. Never mind. Anyone want to say what feature? Don't say how it's going to change it, just what feature gets changed by that 3. Anyone? So that's going to change the period. It's going to compress it by a factor of 3. So that's the frequency has changed, the wavelength has changed, and it means that also the step size as you go from middle to high to middle to low to middle. Each of those steps is now going to be compressed by a factor of 3. Okay. And let's do one more. Let's put in a C. Now this needs to have pi in it. Okay. You've got to put something in with pi. Who wants to type something in? A fraction or a whole number of pi? I don't mind what you do. Somebody choose one. Anyone? Pi over 2. Thank you, Samantha. Right. So we've changed it one more time. And now we've got y equals to sine of 3x, let's do minus pi over 2 plus 4. This is not yet in graphing form. So that start is not pi over 2. Tell me where would this start? Write this on your graph, on your piece of paper. And the hint is it is not going to be at either plus or minus pi over 2. You have to factor out that 3. Think about what that would be like. Okay, guys, and then you need to graph that and submit it, okay? So I'm going to, then there's also a homework, which I haven't posted for you yet, but your classwork today, as soon as you've got that graphed, I'm going to create a module for it right now. It'll take me about 5 minutes, okay? But submit that work and then you can get on with your homework. And you're welcome to stay in the class if you have any other questions for me, but don't ask me a question for about 5 minutes.